This video is going to look at section 4 of Leaving Certificate Functions Note, and in particular this section focused on graphing linear functions. So graphing linear functions shouldn't be too difficult because we were actually graphing linear functions when we were doing coordinate geometry of the line and we were graphing lines. So what a linear function stands for. So when functions with no squared or cubic numbers are graphed, they form lines. So these functions are called linear functions. So we've graphed lines before, so this is hopefully just recapping how you draw graphs. So some examples of kind of what linear functions would look like. So we have f of x is equal to 3x minus 7, g of x is equal to x minus 4, we have L of x is equal to 5x minus 12, h of x is equal to minus 2x plus 5, and k of x is equal to a quarter x plus 2. So graphs can come in many different shapes and sizes. Linear ones can kind of look like they have an x stuck on and maybe a number sometimes. Of course, a linear function we could also have would be f of x is equal to 2x. There doesn't need to be a number on the end of it. Or we could have g of x is equal to a half. That would be perfectly normal as well. So in order to draw a linear function, you need to find 2 points. Plot the points on the coordinate diagram and join the points together with a ruler. The easiest way to find 2 points is to find where the function cuts the x-axis and the y-axis. Now in the last video we briefly touched on this, but you should 100% know it from coordinate geometry of the line. Before we look at graphing a linear function, there's one key thing that I want you to remember. So on a graph, f of x or f dot x stands for y, and we kind of introduced that in the last few videos, so I'm hoping that it'll be nothing too difficult. Now going back to how to graph linear functions, so to find where a point cuts the x-axis, take the function, replace f of x with 0, and solve the equation to find the value of x. This value of x is the x-coordinate of the point and is called the x-intercept. Now I'm going to just do that with this point up here. So f of x is equal to 3x minus 7. So we're trying to find where the graph cuts the x-axis. So we let y equal to 0. So remember that we can rewrite this as y is equal to 3x minus 7. Y is 0. So this becomes 3x minus 7. I'm going to plus 7 to both sides. So we'll get 7 is equal to 3x. I'm going to leave this as 3x is equal to 7. So then x would be 7 over 3. So then where this line cuts the x-axis is 7 over 3, 0. Now, then we need to figure out where the line cuts the y-axis. So again, y is equal to 3x minus 7. And in this case, to find where a line cuts the y-axis, take the function and replace f of x with y and x with 0. Solve the equation to find the value of y. This value is the y-coordinate of the point and is called the y-intercept. So we get y is equal to 3 times 0 minus 7. So then y is equal to minus 7. So the y-intercept is 0 minus 7. So we're going to figure out how that will help us when drawing a graph in the next slide. But for now, you need to be really comfortable with finding where a graph cuts the x-axis and finding where a graph cuts the y-axis. Question 4.1 asks us to draw the graph f of x is equal to x plus 3 in the domain where x is between minus 2 and 3. So, as I said, the first thing we need to do for this is find where the graph crosses the x-axis and y-axis. Now, when the graph crosses the x-axis, y is equal to 0, and when the graph crosses the y-axis, x is equal to 0. So, we have f of x is equal to x plus 3. Now we know that f of x is y, so y is equal to x plus 3. Now the first one we're going to go with is the x-axis. So we know that y is 0 when it crosses the x-axis, so we're going to sub in 0 for y, so x plus 3. So we can take 3 from both sides, and we get minus 3 is equal to x, so then x is equal to minus 3. So the coordinates of the point where the graph crosses the y-axis is minus 3, 0. And then when across the y-axis, we have x is equal to 0. So again, we have y is equal to x plus 3. We're going to replace x with 0, so we get y is equal to 0 plus 3. So y then ends up being 3. So then the coordinates of the point where it crosses the y-axis is 0, 3. Now the next thing we have to do is draw that graph. So we had the points that it was minus 3, 0 and 0, 3 where it crossed the y-axis. So to draw this, the first thing we're going to do is draw our x and y axis. Of course, you'll be doing this in your maths copy. It'll be much neater. It'll be done also in pencil. So we're going to write in our points. So 1, 2, 3. Now, then all we have to do is plot the points. So for this one here, it's minus 3, 0. So we come across minus 3 and we go up 0, which stays the same. So this is the point where it intersects the x-axis. And then we have to plot the other point, which is 0, and we go up 3. So the blue point here is where it intersects the y-axis. Then you get your ruler and you draw a line between both. And this, then you just label as f of x is equal to x plus 3. The next thing you need to know about linear functions is whether they are increasing or decreasing. So we always analyse graphs from left to right. So we read English from left to right. So we read graphs from left to right. And that's the key thing we have to take from this here. So a linear function is increasing when the graph is going uphill, and a linear function is decreasing when the graph is going downhill. So we read from left to right. So we start here and we work our way right the way over towards the other side of the whiteboard here. So if you look at the graph here, this one is increasing because when you're reading it here, it's going uphill, and this graph here is decreasing because it's going downhill. I'm hoping that's okay. The next thing we need to be okay with is proportional and non-proportional functions in graphs. This can get a little bit confusing and people get confused between it, but there's 3 definitions, and if you know the 3 definitions, it should be easy enough. So a function is proportional if it forms a straight line when graphed, and we know that when graphed, linear functions form a straight line. So all linear functions are proportional. A function is non-proportional if it does not form a straight line when graphed. So examples of them would be quadratics. There are U and N shaped graphs. We'd also have cubic, which we'll be looking at graphing too, and exponential, which we'll also be looking at graphing later on. Now, the key one is whether it is directly proportional. So a function is directly proportional if it is a straight line, so bearing in mind that it's proportional if it's a straight line, so it has to be a linear function, and it goes through the origin, making sure that you know the origin is 0, 0. So a directly proportional graph forms a straight line, so it's linear, and it goes through the origin. Okay, so there's a few examples here that we can look at. So the first one, we have the graph that's in blue, and we have the coordinate plane behind it. So if I was to ask you whether, first of all, is this graph increasing or decreasing, and then if it was proportional or non-proportional or directly proportional. So the first thing to say whether it's increasing or decreasing, we start on the left and we go towards the right, and we say to ourselves, is it upward hill or downward hill? And in this case it's a downward hill, so this function is decreasing. And then we say, okay, is it proportional? So proportional, remember, means it forms a straight line when graphed. So this line is straight, so it is a proportional graph. However, is it directly proportional? So we look for the origin, and the origin is here. And you can see that the graph is not graphed straight to the origin, so it's not directly proportional. The second example then, we ask ourselves the same question. So is it increasing or decreasing? Is it proportional, not proportional, or is it directly proportional? So the first thing is it increasing or decreasing? So we start on the left hand side and we work our way over to the right hand side. And we ask ourselves, is it an upward hill or a downward hill? And of course this one is an upward hill, so it is increasing. And then we say to ourselves, right, is it proportional? So proportional means, is it a straight line when it's graphed? And this function definitely is a straight line, so it is proportional. And then we ask ourselves, is it directly proportional? So is it going through the origin? And you can see here that this graph is directly going through the origin, so it is directly proportional. Now, the final one then, we have a look here. We're not going to ask ourselves the question, is it increasing or decreasing? And the reason why is because this isn't a linear function. We haven't looked at quadratic functions yet, but when we do look at quadratic functions, we will talk about whether they're increasing or decreasing. So then we ask ourselves, is it proportional? And proportional means, is it a straight line? So no, it's not proportional. So then automatically it's non-proportional. And then we ask ourselves the question, is it directly proportional? Now, remembering again that for a function to be directly proportional, it needs to go through the origin. And as we can see here, this definitely does go through the origin, but it's not a straight line. So there's two criteria to be directly proportional. The first one being that it needs to be a straight line, and the second one being that it needs to go through the origin. This question is kind of combining graphing linear functions and then showing whether they are proportional, directly proportional, increasing or decreasing. So it says a motorbike uses petrol at a rate of 1 litre per 20 kilometres. Copy and complete the table below to show the petrol consumption of the car over a journey of 100 kilometres. So this should be no problem at all. So if he uses 1 litre per 20 kilometres, so if he travels 0 kilometres, he's going to use 0 litres. If he travels 20 kilometres, he's going to use 1. 40 kilometres, he's going to use 2. 60, 3, 80, 4, 100, 5. So draw a graph to show this information. So on the Leaving Cert exam, you don't really need to know exactly where to draw a graph in terms of what goes on the x-axis or what goes on the y-axis. They're more concerned about the maths that you're doing for it. So most likely in the exam, when you're asked to draw this, they will give you the graph. So I'm going to draw the graph now. Now, so the one thing that we do have to be able to do though is fill in the graph. So the distance along here, we have, this would be 0, 20, 40, 60, 80, and 100. And the distance, the petrol, we'd have 0, 1, 2, 3, 4, 5. Now, then we need to be okay with plotting them. I'd always plot them in a pen, so maybe red pen. So 0 plots with 0, which is there. That's perfect. 20 plots with 1. 40 with 2. 60 with 3. 80 with 4. 100 with 5. Now, of course, when you plot this using your graph paper, it's going to be much neater, much tidier. And then you just finish by joining the dots together. So that's the first part there. So we've drawn the graph as shown in the information. So then they ask you, is this graph directly proportional? And explain your answer. So remembering that there's two criteria for the graph to be directly proportional. The first one being that it is a straight line. And the second one is that it contains the origin. So if you look at this line here, it is a straight line and it also does contain the origin. So it is directly proportional. Now, a lot of people then would ask, well, how can I explain that? Well, you explain it by saying, you first of all say it is directly proportional, then you say because it is a straight line and it contains the origin. That's the definition of directly proportional. The third part then says take two values, find the equation of the line. So to find the equation of the line then, we need the formula. So y minus y1 is equal to mx minus x1, where m is the slope. So here we know the slope is y2 minus y1 over x2 minus x1, all from your formula and tables booklet. We can take 2 points, we'll take 0, 0, and we'll also take 21. So this is going to be x1, y1, and this will be x2, y2. So to get the slope, it's going to be y2, which is 1, minus y1, which is 0, over x2, which is 20, minus x1, which is 0. So the slope for this one is 1 over 20. Then we can fill it in. So I'm going to use x1 and y1. So y minus 0 is equal to 1 over 20 by x minus x1, which is 0. So this will become y is equal to 1 over 20x. Then what we'll get is that this is 20y is equal to x by multiplying both sides by 20. Now, if we have a look here, just make sure we know what x and y is. So x in this equation and y in this equation. So x in this equation stands for the distance, and y stands for the petrol consumption. Now, so the final part, so this was part I. So the final part, use the equation you have found to find the amount of petrol consumed for a journey of 65 kilometers. So the distance in this case is equal to 65 kilometers. We know that 20y is equal to 65, so then y in this case is going to equal to 3.25 litres. And that's the end of this video.